Alright, next example is for dissociated adsorption or atomic adsorption. Okay, consider the isotherm for carbon monoxide absorbing as atom. Therefore, 2 adjacent vacant active sites are required. Then, first step, remember the first step, you need to write the rate law, the net rate of adsorption. So, in this case, okay, RAD equal to Ka PCO CV square minus K minus A CO dot S CCS, right? And then relate it with the equilibrium rate constant, then you will get the net rate of adsorption as the last equation here. RAD equal to Ka PCO CV square minus CO dot S CC dot S per Ka. So how we get this equation is from the mechanism of dissociated adsorption in the previous slide. So you can refer it at the from previous slide. Okay, I can't remember which page. Okay, then next step, write the site balance. So in this case, because you have carbon and oxygen that attach to the active site, therefore the site balance is Ct equal to Cv plus Cc dot S plus Co dot S. So that's the difference between non-dissociated and dissociated. Okay, so you can look at based on the site balance and also based on the net rate of adsorption. Then at equilibrium, you will get this equation. So actually at equilibrium is RAD equal to 0. So when RAD equal to 0, then rearrange the equation, we will get this equation. Okay. Then consider, this is just for example, consider the concentration of C dot S and concentration of O dot S are equal to each other. Okay, then solve it. Then you will get the adsorption isotherm of oxygen that attached to the active site as this equation. The concentration of oxygen that attached to the active site, CO dot S, equal to this equation. This is the last equation is the adsorption isotherm of adsorption of oxygen. Okay, so similar for adsorption isotherm of carbon, right? Okay, next we look at the step 4 of reaction. Step 4 of reaction is surface reaction, the most important steps in catalytic reaction. Why? Because at this step, the product will produce. Okay, first we need to know the surface reaction model. So the rate of adsorption of species A, okay, from previous step, from previous adsorption step in step 3. So the adsorption of A plus S, reversible reaction A plus dot S. So this is the net rate of adsorption. RAD equal to Ka PACV minus Ca dot S per Ka. So this is from step 3. Then in step 4, it can be divided into 3 types. Okay, the reactant that has been adsorbed onto the surface, bermaksud A dot S ni tadi, it will react in a number of ways. Either single site, dual site, or Illyrideal mechanism to produce the product. Okay, first we look at what are the differences between single site, dual site, and Illyrideal mechanism. Okay, single site mechanism. Surface reaction with single site mechanism ni usually if the reaction only involve one reactant. Okay, so kalau adsorption, we need to relate it with the adsorption step. If adsorption step is in non-dissociated adsorption and only one reactant, so meaning that during the surface reaction, it will continue via single site mechanism. Or if the only one reactant, let's say reactant A, you only will have one reactant, and then reactant A attached to the active site and produce A dot S during adsorption step, and it will continue with single site mechanism during surface reaction. Okay, for example here, for one reactant, the reaction mechanism is elementary in each step. Therefore, the mechanism to produce the product A dot S, reversible reaction to produce product B dot S. So if you look at the diagram here, the picture, A attached via ring dekat triangle ni, this one is from adsorption step previously. And then surface reaction occur, will produce the product B that attached at the same active site. Okay, so B dot S. So dah maksudnya dah jadi product. And from here, the mechanism shows that the reaction is reversible reaction. Therefore, write the net rate of surface reaction. But remember, in surface reaction, it can be reversible or irreversible. So it depends on the properties of reaction. So you need to aware only absorption and desorption reaction yang always reversible. But for surface reaction, it can be reversible or irreversible. Okay, next step. Next, we look at the example of dual site mechanism. So the adsorbed reactant interact with another site, occupied or unoccupied, to form the product. So for this dual site mechanism, dia tak kira. Either it is one reactant or two reactant, but the product produced at another active site. Okay, for example here, A dot S, okay, if you look at the picture, the diagram, A attached on the active site S, okay, and then ada another vacant site ataupun unoccupied active site. And then when the surface reaction occur, the product will produce at another triangle, not the same triangle as A. Okay, so dia akan produce ataupun attach, the product will attach with another unoccupied active site. So this reaction we'll call dual site mechanism surface reaction, because the reaction require two active sites. So the mechanism is A dot S plus S, reversible reaction B dot S plus S. Okay, then based on this mechanism, write the net rate of surface reaction. So adsorb A react with an adjacent vacant site to yield a vacant site and absorb product site. Okay, so maksudnya the product is B, product B that attached to the active site and another vacant active site. Right. So for dual site mechanism ni, dia ada banyak jenis. Yang ni one of the example when only one reactant involved in the reaction, but the reaction required two active site. Okay. Another, sorry. Okay. KDC equal to 1 over rate equilibrium constant of absorption of species C. Okay. Therefore, RDC equal to KD bracket C dot S minus KC PC CV. Or if you want to leave it as the previous equation yang tak ada term, tak tukar term, tak relate kan dengan equilibrium constant ni pun tak apa. So, kalau you nak leave it as the second equation in this page pun tak apa. Okay, if you want to leave it as this equation. So, it's up to you. Okay, then this is the one of example of absorption isotherm. How to derive this absorption isotherm, I will show it in the example video. Okay, I think that's enough for this session.